4 kilometers of laser beam held in vacuum, watching for a stretch of 1 part in 10 to the 21. That is 1,000th of the width of a proton, measured across a distance you could walk in an hour. And in 2015 it moved. One arm lengthened while the other squeezed, a tremor that is not a tremor in space, but a tremor of space. Now put that beside the picture this series has been building. If space is a locked lattice of rotors, then something concrete has to be doing the trembling, not an abstract metric, a field on a substrate. And the substrate already tells you which field it must be, because the speed of light here is not a constant handed down from outside. It is set by the stiffness of the lattice. Stiffer substrate, faster cone, so let the stiffness shiver, and the light cone shivers with it. That shiver quantizes the graviton of this theory. This chapter builds it from the substrate up, and then counts its polarizations. The count comes back 1. Einstein's graviton carries 2. That difference is the whole story, and we are going to face it head-on. One thing before we begin. Advaita Chakra Theory is a speculative, exploratory framework, not established, peer-reviewed physics. Much of what follows is honest conjecture that still needs validation. Watch it in that spirit as ideas to test, argue with, and refute. Start with the 2 suspects, laid out plainly. Either the free spectrum of the locked lattice contains a propagating transverse traceless tensor, that is Einstein's graviton, 2 polarizations kept massless by an emergent local diffeomorphism symmetry, or the substrate's 1 guaranteed geometric fluctuation is something simpler, and our job is to derive exactly what. The elimination is quick. In the locked phase there is precisely 1 geometric thing that can wobble without paying any locking energy, and that is the cone itself. Here is why. Chapter 3 gave us the emergent light speed c effective squared equals the lattice spacing squared times the intersite stiffness divided by the inertia. Read that again as a statement about what is fixed and what is free. The spacing is an input, 1 length scale. The inertia we hold fixed. The stiffness is a coupling, and wherever the stiffness varies, so does the cone. So let the stiffness fluctuate about its locked value. Take the logarithm of that speed law and the square root hands you a factor of 1/2. The fractional change in the cone is exactly half the fractional change in the stiffness. That dimensionless fractional cone fluctuation is what a detector calls the strain. It is 1 real number at every point in space. 1 number. A scalar. Hold on to that, because carried through the quantization, it is the fact that decides everything. Now we need its dynamics. Expand the effective geometric action about the locked ground state. The long wavelength behavior of a locked phase is governed by the Goldstone quadratic action, and its 2 derivative form is fixed by 3 things: locality, the shift symmetry of the flat direction, and the single Lorentzian principal symbol of the fully locked phase. Write the cone as its locked value times 1 plus the strain, expand to second order, and you get the free field action of a massless scalar, kinetic term minus gradient term. Look closely at the coefficient in front of the gradient term. It is the emergent light speed, not some independent gravitational wave speed. And that is not a convenience. It is the physics. The strain is a fluctuation of the very same Goldstone cone that carries light and matter, so a Goldstone always rides its own acoustic metric. Tensor sector, Goldstone sector, matter sector, 1 characteristic cone. Vary the action and you get the equation of motion strain acceleration minus the cone speed squared times the Laplacian of the strain plus a gap term. Second order in time. Now, why does second order matter? Because you might have guessed geometry relaxes a diffusion. First order in time, strain dot goes like the Laplacian. The substrate forbids it. Axiom A1 says the microscopic dynamics is deterministic and time reversible, and a reversible Hamiltonian flow simply cannot produce a dissipative first order law. The leading time reversal invariant equation of motion is the wave equation. Geometry propagates. It does not seek. That gap term deserves a beat of its own, because it is the one place this chapter must not overstate its case. The strain is the log fluctuation of the cone. But by the protected identity of chapter 10, the log fluctuation of the cone equals the log fluctuation of the condensate amplitude, and that object already has a name in this book. It is the amplitude dilaton, sigma, the very field whose equation of motion chapter 12, derived from the substrate's own Gross-Pitievsky limit, complete with a mass supplied by the locking. So let us be blunt about it, the strain is that field. There is no second, separately massless geometric field standing alongside it. What the wave equation therefore says is narrower than it first looks. The strain is gapless only above the gap. For wave numbers much larger than the gap frequency divided by the cone speed, that is, wavelengths short compared with the condensate healing length, the mass term is negligible, the dispersion is linear, and the strain rides exactly the same cone as light and matter. That is the one-cone spine of the whole book. Below the gap, the same field is the Yukawa screen dilaton of Chapter 12, and the honest verdict of Part 3 applies to it unchanged. So every result in this chapter is stated in the short wavelength regime, where the gap can be dropped, and each survives the gap being put back, with the frequency squared, simply shifted upward by the gap squared throughout. The wave equation is the continuum limit. But this substrate is a lattice, and a lattice always signs its name. Solve the exact nearest neighbor problem instead of the continuum one, and the dispersion is not a straight line, it is a sine frequency equals 2 times the cone speed over the lattice spacing, times the sine of half the wave number times the spacing. Exactly the same sinusoidal form that governs every other mode of the substrate. Expanded for small wave number, and the leading correction to the squared frequency is a negative quartic tail. The fractional shift is -1/12 times the wave number times the spacing, all squared, equivalently -1/12 times the ratio of the energy to the Lorentz violation scale squared, where that scale is Planck's constant times the cone speed divided by the lattice spacing, the very same scale Chapter 7 found in the photon sector. Now, how much of this is a real prediction? Be careful here. The coefficient -1/12 is the symmetric limit value. The robust, falsifiable content is not that number. It is two things: the negative sign, meaning gravitational waves go subluminal at high wave number rather than superluminal, and the fact that the scale is the same lattice spacing that appears in the photon and matter sectors. The gravitational wave is slowed at high energy by exactly the amount light is locked to one spacing. That correlation across sectors, not any single sector shift, is the discriminant that Chapter 34 develops. So we have a free field obeying a wave equation, and underneath it axiom A2 quantized rotors, integer angular momentum makes the substrate a genuine quantum system. So quantize the strain. This is the textbook move, and I want to flag it as textbook. Promote the strain and its conjugate momentum to operators. Impose the equal time commutator with a delta function. Expand in the normal modes of the lattice dispersion. That commutator step is standard canonical free field quantization, and we tag it standard and hand the credit back. What is derived is what it produces here. Substitute the mode expansion into the quadratic geometric Hamiltonian, and it diagonalizes completely. The geometry becomes an independent harmonic oscillator for every single lattice mode, each at the sine frequency we just derived. The Fock states built by the creation operators then count indivisible quanta of geometry, each carrying 1 unit of Planck's constant times its frequency, riding the emergent cone. Those quanta are what this chapter is named for, lattice gravitons. And I use the word graviton in its precise technical sense, and no other, the quantized excitation of the geometric wave equation. That is what has been built, and the construction is the derivation. What kind of graviton it is, how many polarizations it carries, is a separate question, and we settle it next by counting the components of the field we just quantized. Now the count, and it is almost embarrassingly simple. Count the propagating degrees of freedom of each candidate. A single real scalar field has exactly one component, and its wave equation propagates exactly one on-shell degree of freedom, one polarization. Now the spin-2 graviton, that is the fluctuation of a full metric tensor. A symmetric 4x4 array has 10 components. Impose the linearized diffeomorphism gauge conditions, and the constraints, and 8 of them are removed, leaving 2, the plus and cross transverse traceless polarizations that LIGO actually detects. So the counts are 1 versus 2, and the field we quantized is the scalar, a single function of position and time. There is no propagating rank 2 tensor anywhere in the free geometric spectrum, because every candidate tensor structure either costs locking energy, it is gapped by axiom A4, or is simply absent. The count returns 1. So the lattice graviton is a scalar gravitational wave. It stretches an interferometer isotropically, a breathing mode, rather than quadrupolarly. And that object is not exotic, it is exactly the non-tensorial breathing polarization of scalar tensor gravity, the one Brands and Dick wrote down, the one in Nordstrom's scalar gravity, and exactly the speed fluctuation mode of analog gravity. What matters for this book is that Chapter 12 reached the identical conclusion from the metric side by a completely different route, a dichotomy argument about which symmetries the locking and the spacing destroy. One object reached 2 ways. It is an honest scalar gravitational wave of the substrate, And it is not spin too. Does it hold up when you actually run it? Work in lattice units and integrate the strain field with velocity verlet, the same symplectic engine that verified the substrate's mode spectrum in part 2. Seed single modes, and the measured dispersion tracks the exact sign form to 0.6% across the entire Brillouin zone. A coherent wave packet travels at the predicted group velocity. The prediction is 0.97, the measurement 0.91, the difference from finite packet width and lattice curvature. Two counter-propagating packets superpose constructively, the overlap peak reaching 0.065 against 0.040 for either packet alone, linear superposition and phase coherence of geometry. A single Fourier mode behaves as a clean harmonic oscillator, with energy conserved to a drift of 10 to the minus 12, the numerical signature that the Hamiltonian really has diagonalized. And there is a lesson hiding in the vacuum. A vacuum must be stationary, its variance must not evolve. The thermally equipartitioned ensemble is coefficient of variation 0.03. But an ensemble started with random strain and zero velocity is not. Its variance sloshes between potential and kinetic energy, coefficient of variation 0.9, which would masquerade as spontaneous graviton production. Stationarity is the criterion that picks the right one. One caveat, stated plainly, the derivation is operatorial, but the numerics evolve a classical Gaussian random field sampling the vacuum two-point function. That is the semi-classical shadow of the Fock quantization, not the operator dynamics, and we say which is which. Let me be explicit about the things this chapter does not claim, because the temptation to overread it is real. It does not claim to have derived Einstein's graviton. The free geometric spectrum of this lattice contains a single scalar, and the tensor is eliminated by direct component counting. It does not claim the fingerprint is measurable in the gravitational wave sector on its own. Put a 100 Hz LIGO band wave in, take the loosest lattice spacing the sky allows, about 2 times 10 to the minus 26 meters from the gamma-ray burst photon bound, and the fractional dispersion shift comes out around 10 to the minus 64. Utterly unmeasurable. That is precisely why Chapter 34 chases the correlated cross-sector version instead. It does not claim the polarization prediction currently passes LIGO, Virgo, Cagra, and the pulsar timing arrays all favor pure tensor content already, and that bounds the physical role of this scalar. To the extent the physical graviton really is spin 2, the strain is a scalar gravitational wave companion riding alongside it, not the tensor force carrier, and it does not claim the door is closed forever. The one thing that would reopen it is an emergent tensor gauge symmetry of string net, Levin-Wen type, arising accidentally at low energy on a different substrate, one engineered so a massless helicity 2 mode emerges collectively and the scalar decouples. The Hamiltonian, this book states, kinetic plus stiffness plus on-site locking, does not contain it. Finding one is a new microscopic model, and it would still owe the 1 part in 10 to the 15 cone unification that GW 170,817 imposes. That is the frontier, not compute the graviton better, but find a different substrate. Verdict. The substrate does have a graviton, in the precise sense of the word, a genuine quantized excitation of a genuine geometric wave equation, derived from the stiffness up, with indivisible Fock quanta each carrying 1 unit of energy on the emergent cone. It is massless above the locking gap, it rides exactly the same cone as light and matter, it superposes and interferes, and it carries the lattice's own fingerprint, a negative quartic dispersion tail at the shared Lorentz violation scale. And it carries 1 polarization, where Einstein's carries 2. That is not a gap in the calculation. It is the calculation's answer, confirmed here by direct component counting and independently by Chapter 12's dichotomy argument from the metric side. The two rotes agree, which is exactly what you want from an honest theory. The Graviton chapter does not secretly outperform the gravity verdict it sits on. So the lattice graviton is a phonon of geometry, the breathing of the cone, real because on this view the substrate is fundamental and analog means actual. Next, stop shaking the stiffness in time and start varying it in space. Add a flow. When the flow outruns the cone, the geometric field we just quantized gets trapped at a horizon, analog black holes, and the Corley-Jacobson result that the lattice fingerprint modulates the Hawking spectrum itself. A word of acknowledgement. This work was inspired in part by the non-dual teachings of Sri Narayana Guru, that the creator, the creation, and the substance of creation are fundamentally one. Symbols from the Hindu tradition. The Sudarshan chakra and the Shiva linga suggested the analogies behind the chakra model. They are acknowledged as philosophical and symbolic inspiration. The physics stands on its own. Thank you for watching. If this made you think, the book and the next chapter are linked below. Until then, one substance and how far it reaches.